Hi everyone, welcome to this new lecture of fluid mechanics. In this lecture, we'll solve a problem on separation of boundary layer. So in the last lecture, we have discussed the concept of separation of boundary layer. So based on the concept, we'll solve this problem. So here the problem I have taken here for the following velocity profile. This is the velocity, three velocity profiles are given here, and we need to determine whether the flow has separated or on the verge of separation or will be attached with the surface. So we need to find out these three conditions from these three equations are there. Okay. So these equations, let's write down the solution for this. So let me consider the first equation. The first equation, what is given? The small u by capital U divided by 3 by 2, and this is y by delta minus 1 by 2. This is y by delta whole cube. So these are the three different velocity profiles are given. Okay, from this velocity profile we need to identify whether the flow has already separated from this boundary layer. So suppose this is the solid object is there. Okay, and when the fluid is flowing over this, and it is flowing with a velocity of u, and the velocity profile will be created over the surface. It's like this. Okay, we have seen previously. Now a point will arise here where that flow is supposed to start separate from the boundary layer, and there from the boundary layer will be separated like this. And one point is there, the boundary layer already separated, and it is having a different form, like it will be started reverse flow will be there in this. Okay, now and previously this is another point, and here we'll get a velocity profile like this. That means the flow is attached to the surface, and this is the point where it's supposed to start separating from the solid body, and next one is already separated. So we need to satisfy at which point or at what condition the fluid is attached with the surface, at what condition the fluid is supposed to start separating, at what condition the fluid has already separated from the surface. That we need to identify. So for this, what I'll do, I'll just keep this small u in one side, and this capital U I'll take it to other side. That is 3 by 2 capital U, and this is y by delta minus u by capital U by 2, and this is y by delta whole cube. Now what I'll do, I'll just differentiate this equation. I'll just differentiate this equation with respect to y, So after differentiating, what I'll get here? So this is del u by del y, and this will be like 3 by 2, and this is y by delta minus here 3 into u by 2, and this is y square by delta q is there. So what I'll do here, this one I'll write delta q, let's write it here like this. Okay, no problem. Now we need to consider this is the equation. Now we need to put the value of at y equal to 0, because we have seen at the surface level of this value y at this point u equal to 0, y equal to 0, because this is the surface level. Now it will be started moving here up to delta. So up to u here, up to u, and the total distance is delta here. So at y equal to 0, what I can write, this is del u by del y equal to 0. That means we need to put the value of y equal to 0 in this. So what I'll get here, 3u by 2 delta. Delta is the boundary layer thickness, u is the velocity, minus here you can see the term y is there, and we need to put the value of y equal to 0. So what I'll get here, it will be 0. Now finally what I got here, 3u by 2 delta. Now so what I can write here, we got the value of del u by del y at y equal to 0. We got a positive value. Okay, so positive value is indicating that the flow will not separate, or we can say the flow will will be attached to the surface. This is the condition actually. If you got the positive value du by dy with respect to y, then we can say this. Now similarly, the second condition, what is given? Second condition is given small u by capital U, and this is 2 y by delta whole square, and this is minus y by delta whole cube. Okay. Now here I can write the same thing. I'll do small u this side and capital L, take it to other side in this way, y by delta whole square minus again capital U into y by delta whole cube. Again just derivative of this. So d del u by del y. So this one will get here 2 into y u and into 2 into y, and we'll get here this is delta square. So this is delta square. Again we will get here capital U, and this is as usual like 3 y square divided by 3 delta. Sorry, this is only I can say let's go back to the previous one. Yeah, so here we can write here delta q as usual, that the whole q is there, we can write this. Now what I need to do, again we need to put the value of to y equal to 0. We need to put the value here del u by del y with respect to y equal to 0. What we can get here, this y value we can see 0, y value also here is there, so 0 minus 0 will get the value of 0. Now finally what I can write here, this is del u by del y with respect to y equal to 0, we got the value of 0. So this 0 value indicating that the flow is in the verge of separation, in the verge of separation. That means it's supposed to start separating from the boundary layer but not separated. Okay, it's supposed to start separating from that. And the third equation is given here. This is small u by capital U. Same method we need to do it here again. Minus 2, this is y by delta, and this is plus, we can write this is y by delta whole square. And here also same thing again, I'll do small u equal to minus 2 into capital U, and this is y by delta, this is plus, we can write here this is y by delta whole square. Again just derive derivative of this term, we can write in terms of dy, that is del u by del y, and this is minus 2 u by delta, and this will be 2 u by delta square, u by delta square. Again what we need to do, we just need to put the value of at y equal to 0, we need to identify what is the value of del u by del y at y equal to 0. So again same thing, at y equal to 0, this is whole cube, no, this is square. At y equal to 0, the value of del u by del y, at y equal to 0, we can write this is minus 2 capital U by delta, and this is y term is there, that's why it is 0. So finally what we got here, we can say del u by del y with respect to y equal to 0, we got negative term, this one. So this negative term indicates that the flow is already separated, or we can say already detached from the surface. The flow is already separated, we can write separated from the surface, or from the body. Okay, so this is our conditions, and all the conditions are satisfied, and based on that we can identify whether the flow is there with the surface, or it is already separated, or it is in the verge of separation. So I hope you understand this problem, how to solve it. Still, if you are having doubt regarding this, you can give a comment on the comment box. Thank you.